Hello all of you. In last lecture we learned about the throughput and bandwidth and the latency. Then next continue with the latency. For example, there is what is the propagation time if the distance between the 2 points is 12,000 kilometer. Assume the propagation speed is to be 2.4 multiplied by 108 meter per second in cable. How to calculate this? The propagation time. For calculating the propagation time, we has the formula, that is distance between 2 points divided by propagation speed. Propagation time equal to 12,000 multiplied by 100 divided by 2.4 multiplied by 10 meter per second if there is a direct cable between the source and destination. Next important performance factor is the transmission time. In data communication, the message containing the bits sent, the first bit may take the time equal to the propagation time to reach its destination. The last bit also may take the some amount of time. However, there is a time between the first bit leaving the sender at the last bit arriving at last bit leaves later and arrive later. The time required for transmission of the message and time equal to the message size divided by bandwidth. Consider the example. What are the propagation time and the transmission time for the 2.5 kbps message, that is an email, if the bandwidth of the network is 1 gbps. Assume that the distance between the sender and receiver is 12,000 kilometer and the light travel at the 2.4 multiplied by 10 raised to 8 meter per second. Here solution is, first we have to calculate the propagation time. Propagation time formula, distance divided by speed, that is 12,000 multiplied by 10,000 divided by 2.4 multiplied by 10 raised to 8, that is 15 meter per second, and transmission time equal to the message size divided by bandwidth. Message size is 2.5 kbps. It must be converted into the bits, that is 2500 multiplied by 8 divided by 10 raised to 9. It is equal to 0.020 meter, that is nothing but the transmission time. Next is the important factor for the performance is queuing time. The third component in it depends upon the loads on the network. When there is a heavy traffic on the network, the queuing time increases. It will be depend upon the router, intermediate router, communication links. Then next is the bandwidth delay product. By bandwidth and delay we measure the performance of the network. In data communication, the product of bandwidth delay is very important. The bandwidth delay product defines the number of bits that can be transmitted by the sender at a given time before waiting for acknowledgement. Let us consider this issue in a hypothetical case, and this is the figures in which we consider these two cases. In case first, let us consider and seconds. Look at the figure. We can say that the bandwidth delay product is 1 multiplied by 5, which is the maximum number of bits that can fill the link. There can be no more than 5 bits at any time on the link. In the second case, assume that we have bandwidth of 4 kbps. It shows there can be the 4 multiplied by 5, that is 20 bits on the line. At each second there are 4 bits on the line. The duration of the each bit delay is 5 seconds and bandwidth equal to the And then jitter. Last performance issue we have to learn about the jitter. Jitter is nothing but it is nothing but the time delay in milliseconds between data packets over the network. Another in technical terms, the jitter is nothing but the packet delay variance. The jitter is considered as a problem when different packet of the data face different delays in the network, and the data at the receiving application is time sensitive, that is for example audio or video. Data in real time data, audio, video on a packet switch network require the preservation of time relationship between the packets of the session. Thank you. We will continue at the next lecture.